So here is the problem. A wire which is 20 feet long is cut to two. One part is bent into a square and the other is bent into a circle. How long is each part to maximize the total enclosed area? How long is each part to minimize the total enclosed area? So let's draw a label. So here is the wire which is 20 feet long and we cut it into two pieces. One piece is Y and the other one has a length of X. Let's assume that this one is bent into a circle with radius R. It means that the circumference of this, which is 2 pi r, is supposed to equal Y. This one is bent into a square. So each side of the square has to be x over 4, because x is 4 times x over 4. So this is the length. Now let's try to find the equation. The equation is that x plus y is 20, but also it means that 2 pi r plus x equals 20. We are going to use obviously the one with r and x. What is the function to be minimized and maximized? It is the total area. So let's now find the total area. From the first one, we get that the area is pi r to the power of 2. And from the second one, it is x over 4 to the power of 2. This is the total area. For the total area, we get that the function to be minimized and maximized is pi r to the power of 2 plus x over 4 to the power of 2. Let's work now in one variable. From here we can figure out what is r. R is 20 minus x over 2 pi. So we plug it into f and we get the new function which has one variable, only the variable x. We really like now to simplify the function f of x. Now you can see that you can cancel out one of the pi's here. So you get only 20 minus x to the power of 2 over 4 times pi in the first part. Now let's take 20 minus x to the power of 2 and we get that. And now we need a common denominator. We will take the least common denominator, which is 16 times pi. And we will get that. Okay, now we want to write it as a quadratic. And we get that. This is now really simplified, at least simplified as possible. So this is the function f. And now we would like to find possible values for the variable. And this is pretty obvious that both x and both y's can be greater or equals to 0 or less or equals to 20. So obviously this has to be a closed interval problem. So the interval of x is going to be 0 to 20, including 0 and 20. So now we would like to find the critical numbers in this interval 0, 20. So let's differentiate. And would like this to be 0. So let's do now some algebra here. Okay, so we get that. Now, it's the important issue. There is only one critical number. Because we need to find maximum and minimum, at least one of these occurs at the end point. Because one is probably going to be the minimum or the max, I still don't know, for this value of x. It means that for the other one, there will be another value of x, but because max and min can occur only at critical numbers and endpoints, if we have one critical number, at least one of the max or min has to occur at the endpoint. But we can observe even more. If you look at the function f, it's a quadratic with the leading coefficient of 4 plus pi over 16 pi, which is definitely positive. It means that this has to be the absolute minimum because of the shape of the graph, which is upward parabola. So now let's use the chart because we need to use the closed interval and we have only one critical number and two endpoints, which are 0 and 20. I'm not going to evaluate the function f in the critical number. This is too difficult to evaluate. But I'm still going to show that this has to be the absolute minimum because, as we saw before, the function f is a quadratic with a positive leading coefficient. So there is only one critical point, which is a local and absolute minimum. It's easy to evaluate at 0 and at 20, so I will. Okay, so when I substitute 0, I get 100 over pi square feet. And when I substitute 20, I get 25 square feet. So we really now have to compare those two numbers. Now, we already have the absolute minimum. So now we're looking for the absolute maximum. So we really need to find out which one of those two numbers is the greatest. So let's see. I know that pi is less than 4. It means that 100 over pi is more than 100 over 4, which is just 25. And I can conclude that this is the absolute maximum. So now let's find the answer. So the absolute minimum is when x equals 80 over 4 plus pi feet. So I need to find the y, which is just 20 minus x, so it's 20 minus 80 over 4 plus pi feet. The absolute maximum is when x equals 0, which means that y equals 20. What does it mean? It means that the whole wire is bent only to a circle.